Hello, everyone. I'm Mr. Furlong, and today we're talking feedback. Organisms have to maintain their internal environments as they respond to both internal and external environmental changes. And they'll do that through the use of a feedback system. There's two feedback systems we're going to talk about today. One is a negative feedback system, which is by far the most common type, and the other is a positive feedback system. Now, you're probably familiar with these without actually calling them negative and positive feedback systems. So, for instance, when it's hot out, you start to sweat. The sweating cools the body down, which brings your body temperature down. That is a negative feedback system. If it's cold out and you start shivering, which will help warm up the body, most types of feedback systems are negative, but let's take a look at the differences between them. In a negative feedback system, and we're going to be focusing on humans for this, in our brain is an area called the hypothalamus. Now, the hypothalamus is monitoring all sorts of things that are going on in the body. And if something starts to get out of norm, the hypothalamus will produce something called a releasing hormone. And there's all kinds of releasing hormones. They go down to the pituitary gland. The pituitary gland is just centimeters away from the hypothalamus. It's at the base of the brain. When the pituitary receives that releasing hormone, it is going to produce another hormone. Let's just call it hormone X. There's all sorts of hormones that the pituitary gland does produce. That hormone X travels throughout the bloodstream and ends up at a gland somewhere. So this is what we call a target gland, which is just a generic name for any gland that a hormone acts on. And that target gland can produce another hormone. We'll call this hormone Y. Now, this hormone does whatever it needs to do, and as it builds up and things get back to normal, the hypothalamus will detect that normality and it will stop the production of the releasing hormone. Because it's stopping the production, this would be a negative feedback system. Now, how is this different from a positive feedback system? There's certainly a lot of similarities. So, for instance, we start with the hypothalamus, and that will produce a releasing hormone, or actually sometimes could just be a quick nerve impulse that goes to the pituitary gland. The pituitary gland then produces a hormone. Let's call this one hormone A. And this goes to a target gland that is then going to cause the production of another hormone. Let's call it hormone B. And this particular hormone, when the hypothalamus detects the results of it, it's actually going to cause more releasing hormone to be produced. When that hormone B causes an increased production of RH, the pituitary gland can produce another hormone, let's call it hormone C, that will then go to the target organ and cause something new to happen. Well, let's take a look at a couple of examples of this. Let's start off with, let's say we have too much blood glucose level. So this will happen just about any time you eat something with a lot of sugar in it, after most dinners. And the hypothalamus is certainly going to pick this up, and it's going to send some hormones to the pancreas. Now, specifically in the pancreas, there are what are called beta cells. When there's too much glucose in the blood, the beta cells are going to release a hormone called insulin. Insulin goes to places like our muscles and our fats, and it causes more glucose to be taken into those cells, which will decrease the amount of glucose in blood. Once the amount of glucose gets back to normal levels in the blood, it's going to cause the beta cells to stop the production of insulin. Because we're stopping the production of a hormone, this is a negative feedback system. So let's say we have not enough glucose in the blood. This is also going to be detected by the pancreas, and specifically this is going to be the alpha cells in the pancreas. So in this case, the pancreas is going to release glucagon. Glucagon goes to the liver that causes the breakdown of glycogen, which is stored glucose, and releases that into the bloodstream. Now, if we don't have any glycogen, it'll take fat and it'll break that down and change it into glucose. Now, once the glucose levels get back to normal, guess what's going to happen? The alpha cells will detect that things are back to normal. It's going to stop the production of glucagon, not where you thought I was going to go with this, isn't it? And this is also a negative feedback system. Right, well, what about a positive feedback system? They are not a whole lot of examples, especially in humans, but let's take a look at one example. At the end of a pregnancy, the baby is going to start to produce a hormone that is going to tell the uterus to start contraction. So the mom's going to begin labor. Right? When the hypothalamus detects that contraction is beginning, it is going to produce a hormone that goes to the pituitary gland. The pituitary gland is going to produce another hormone called oxytocin. Now, what oxytocin does is it increases the number and the severity of the contractions as labor is continuing to progress. The more contractions that the female has, the more oxytocin she's going to make. So that is a positive feedback system, but we're not done yet. As oxytocin levels begin to increase, that is going to cause the pituitary to produce a hormone called prolactin, which is also a positive feedback because increased oxytocin causes more prolactin. Prolactin's job is to go to the mammary glands, which is then going to produce the milk, which is also going to be a positive feedback. But after labor is over and the baby's been delivered, that milk production needs to continue. Now what's going to keep that milk to continue to be produced? Well, this is where the baby comes in. As long as the baby is nursing, prolactin is still going to be made, which is still going to cause milk to be produced, which is also a positive feedback. But once the baby stops nursing, guess what? Prolactin isn't going to be made anymore, and because we're stopping the production of that hormone, that's a negative feedback system. And so then the milk production will end up stopping because there's going to be no more prolactin. Wow. That was a lot. Understanding these feedback systems is very important. And also understanding that it's not just things that take place in us. These feedback systems happen in plants and animals. That happens in the environment. We're going to take a little bit deeper dive into feedback systems in class. And I'll see you then.